Okay, so what I would like to do is take you through a very detailed solution of how to solve a linear system. Actually, just going back to what a linear system is. So, up until now, we've been looking at linear equations, and they've just been single linear equations that have been used to describe situations. But what we want to do now is we want to be able to take those linear equations, linear relationships, and compare them so that we can make some decisions. And believe it or not, this is something that you probably do on a regular basis in your real life. We're just kind of formalizing the process and being able to analyze the data a little bit more. So I'm going to look at a situation where I'm comparing costs of plumbers. So my dishwasher broke. I'm trying to decide between two plumbers. Plumber number one charges $36 per hour for labor, plus $50 for the service call. So if somebody comes to your house to fix something, they'll often charge you a fee just for coming to your house. So that would be the service call cost. Plumber number two charges a little bit less, so $35 for the service call, but their hourly rate is a little bit more, $39 per hour. So I need to make a decision of what plumber I should choose. So what I want to do is I want to analyze this information in detail and do it in a way that I can compare the two plumbers and what the costs are going to be uh, in connection to each one. So the first thing that I always do is I always think about it in a table of values, and I like to create a double table of values so that I can see side by side how the costs compare. So when I create my double table of values, I know that I've got two things that I'm looking at. I'm looking at the number of hours that they're going to come for, and I'm looking at the cost. So my independent variable is the number of hours. That's what I'm in control of, and that's what the cost of each plumber is going to depend on. So I put that first as my independent variable, and then I'm going to look at how the cost of plumber one depends on the hours, and the cost of plumber two depends on the hours right beside it. And I'm going to put them all together so that I can compare as I go. So I know for plumber one at time zero, so just for the service call, plumber one's going to charge $50 and plumber two is going to charge $35. After 1 hour has gone by, so if the plumber leaves after 1 hour, for plumber one, I will have paid that initial $50 plus the additional $36 an hour. So I'll pay a total of $86 for plumber one. Whereas for plumber two, I've paid the initial $35 plus an additional $39. So I'll have paid them um, $74 altogether. Okay. And then I can continue that. So after hour two, I'm going to add on $36, add on $36 for three, add on $36 for four, add on $36 for five, add on $36 for six, and so on. So I can create my what the total bill would be for plumber one after various numbers of hours. Okay. And I'm going to repeat that for plumber two. So after another hour added on to the first hour, I would add on additional $39, another $39, another $39, and so on and I just chose to put mine up to 10 hours just so I could get a good picture of what was going on. So once we create the double table of values, it becomes a little bit more simple to be able to compare the prices. So first of all, when I look at my table of values, the first thing that kind of pops out at me is this value right here. And I highlighted it because it's a really important value. So after 5 hours, the cost of hiring plumber one would be $230 altogether. So that would be my bill from plumber one. And my bill from plumber two would also be $230. So if I was kind of thinking, okay, I think this is going to be a long job, 5 hours to fix my dishwasher, it wouldn't matter which plumber I chose, plumber one or plumber two, the cost would be the same. So it doesn't matter which one I choose. Okay. However, if we think it's going to be a shorter job, so a job that's maybe below 5 hours, so between 0 and 4, if we compare the numbers, you can see that for every value below 5 hours, plumber two is going to be the cheaper option. So all of these numbers are lower than plumber one. So plumber two is going to be the cheaper option. We hit 5 hours, they're the same. But then after 5 hours, again, if you look closely at the numbers, it switches. So now all of a sudden, plumber two becomes the cheaper option, because all of these costs are less than the cost for plumber 2. So before plumber 1, sorry, at 5 hours, they're the same. For everything below 5 hours, plumber 2 is cheaper, and for everything above 5 hours, plumber 1 is cheaper. Okay, so there's a good visual of some solid concrete numbers that you can use to make some decisions with. I always like to visualize it on a graph as well. So what we want to do is we want to take this double table of values in the same way that we put them into the same table of values. We're going to plot both of those lines on the same graph. So I created a graph. So again, I have my independent variable on my x-axis. So I have my number of hours. Oops, I forgot to write that on there. That should be number of hours labeled on my x-axis. I chose to go up by ones to get up to at least my 10 there, which I had in my table of values. And then on my dependent variable is going to be my cost, because my cost depends on the number of hours. And then what I do is I plot the data for both plumbers on the same graph. So I took these points in the table of values for plumber 1, I plotted them on here. I did it in green so that you would, and then I made sure I labeled it so that the reader knows that the green line is the cost for number 1. And then I took my data for plumber number 2, I plotted it on the graph, and I chose to do it in purple so that the reader would know that that data was for plumber number 2, and I made sure I labeled it. And now I have a little bit more of a visual of what's going on in that table of values. And just like the table of values, you'll see that at 5 hours, both the costs were $230, and that's where those two lines cross. We call that the point of intersection. So the point of intersection, we can see that both costs are the same for the plumbers. But if we look below that point of intersection, you'll notice that the purple line, which is plumber number 2, the purple line is a little bit lower. So we can see visually that the cost of plumber number 2 is going to be cheaper. So everything below that point of intersection, plumber 2 is cheaper. That switches after the point of intersection. So after the point of intersection, you can see that the green line becomes the lower graph, and that is plumber number 1. So because it's lower, I know it's cheaper, and I can say that plumber 1 is cheaper because the line is lower. Okay, so the graph basically takes what we did in the table of values and gives you a good picture and a visual of what's going on with that information. Okay, so now this is a little bit of an open-ended question because it says what value or what plumber should I choose? But it doesn't tell me how long the service call is going to be. So based on this information, what I want to do is I want to create a detailed conclusion that I can then use to make decisions with. So I'm going to start with this part of the graph right here. In my 3-part conclusion, I can say if I need less than 5 hours of work, I'm going to choose plumber number 2 because for less than 5 hours of work, plumber number 2 is cheaper. In my second point, I'm going to say, okay, well, if I need exactly 5 hours of work, it doesn't really matter which plumber I choose because the cost will be the same. So it doesn't matter. But if I know this is going to be a really long job and I know I need more than 5 hours of work, then I'm going to choose number 1 because plumber number 1 is cheaper after 5 hours of work. So because this is an open-ended question and doesn't give you specific details about how long the job is going to take, you want to make sure that you write a 3-part conclusion so that you have all of the scenarios described. And then from there, once you get more information about the problem or once you analyze your own situation, you can decide which plumber would be the best option. Okay, so again, this is stuff that we kind of do in our heads regularly. At least I do, having my own house and kind of living in society where I'm buying things and making decisions about my buying choices. This is just formalizing that information and looking at it in detail and connecting it to some of the math that we do in our heads every day without maybe even realizing it.